On March 16th, 2026, something happened across the United States that meteorologists said should not have been physically possible in a single day. In the Great Lakes region, a blizzard dumped snow by the foot. At the same time, in the eastern part of the country, damaging high winds were marching across multiple states with tornadoes embedded inside them, followed immediately by a plunge of Arctic cold. In the southwest, an unprecedented heat wave was taking hold, with Phoenix forecast to hit 107 degrees Fahrenheit, a temperature the city almost never sees before May. In Hawaii, more than 2 feet of rain fell in a single stretch. And at the same time, drought was gripping more than half the entire country. Snow, tornadoes, extreme heat, catastrophic rainfall, and drought all on the same day, all in the same nation. Climate Central Chief Meteorologist Bernadette Woods-Plackey said it plainly: it is unusual for everything to be at the absolute extreme levels they were experiencing at once. And the reason all of that happened simultaneously has one single cause sitting 8 to 12 kilometers above your head right now: the jet stream. And in 2026, scientists studying it have become more concerned than they have been in years, because the jet stream has started behaving in ways that break its own historical pattern. Today, we are breaking down exactly what changed, what the new research says, and why meteorologists keep using the word structural instead of the word unusual. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Has your local weather felt more unpredictable the last couple of years? Tell me your region and what has changed. If you want to be the first to know every time a major weather pattern shifts, subscribe to the channel right now. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one so the algorithm actually shows it to the people who need to see it. Thank you. Now, let us get into it. First, the basics, because you need this to understand why scientists are worried. The jet stream is not weather itself. It is the engine that arranges weather. It is a ribbon of extremely fast-moving air, typically found between 8 and 12 kilometers above the surface, that circles the entire Northern Hemisphere. Its entire job, in simple terms, is to separate cold Arctic air from warmer air to the south, and to push weather systems from west to east so that no single pattern, whether it is rain, heat, or cold, sits in one place for too long. Under normal conditions, the jet stream moves in a relatively straight line, or with gentle rolling waves. When it is behaving normally, a heat wave lasts 3 or 4 days and moves on. A cold snap lasts a few days and moves on. The jet stream is, in effect, the thing that keeps weather temporary. What scientists have been documenting with increasing alarm over the past several years is that the jet stream is no longer moving in gentle waves. It is developing enormous, deep loops, the kind that plunge far to the south or swing far to the north, and then, critically, it is getting stuck there. Instead of a wave passing through in a day or two, a loop now can lock in place for a week, 2 weeks, sometimes longer. When a loop plunges south, it drags Arctic air down with it, causing a cold snap or a blizzard in a place that should be entering spring. When a loop swings north, it pulls warm air up into a region and then traps it there, which is exactly the mechanism behind a heat dome. This locking behavior is what turned March 16th, 2026 into a single day containing a blizzard, tornadoes, a heat, wave, and a flood, because different loops of the same destabilized jet stream were parked over different parts of the country at exactly the same time. Meteorologist Jeff Masters of Yale Climate Connections described the Southwest heat event from that same period as the type of extreme heat you could not get without human-caused climate change, adding that the extremity was so ridiculous that 50 years ago you would not have seen it at all. Climate. Scientist Michael Mann at the University of Pennsylvania has published research showing that the kind of large-scale planetary wave pattern responsible for these locked loops is increasing in frequency in a warmer world, particularly across the April through September window, though he has been careful to note that extending that pattern into March, as happened this year, is still a more speculative and newer trend that researchers are actively watching. So why is this happening? The leading explanation comes down to a process called Arctic amplification. The Arctic is warming significantly faster than the rest of the planet, in some assessments 2 to 4 times faster than the global average. The jet stream exists and maintains its speed specifically because of the temperature difference between the cold Arctic and the warmer air to the south. Think of it like a river flowing downhill. The steeper the slope, the faster and straighter the river runs. The jet stream works the same way, powered by the steepness of that temperature gradient. As the Arctic warms faster than everywhere else, that gradient flattens. The slope gets gentler, and a gentler slope produces a slower, weaker, wobblier current, one that is far more prone to buckling into large stationary loops instead of flowing steadily west to east. This is not a fringe theory anymore. In 2026, atmospheric scientist Daniel Swain, who tracks western United States weather patterns closely, flagged the Pacific jet stream as unusually active for the month of June, with what he described as a notable extension stretching from the West Pacific all the way to the East Pacific. He explained this unusual configuration was already producing a changeable, repeated sequence of late-season low-pressure troughs and dry wind events through May and early June, before setting up a broad, strong ridge of high pressure that brought a dramatic warming trend to the Pacific Northwest and Northern California by mid-June. In other words, the same destabilized jet stream that produced a blizzard in March was still producing anomalous, locked-in patterns 3 months later, just in a different location and a different season. Separately, climate researcher Erica Desjardins analyzed the extreme heat dome that hit the southwest United States earlier in 2026 and published her findings under a title that says, "Everything You Need to Know: Why the Ridge Keeps Coming Back." Her argument was that the March heat dome was not an isolated random event. It was, in her words, the most extreme pulse inside a winter-long pattern that had already locked the western United States into unusual warmth for months, while the eastern part of the country experienced the opposite, a persistent cold pattern. She described this as a warm west, cool east dipole that has become a recurring feature of North American winters over roughly the past decade, and she argued that this points toward a structural shift in winter atmospheric circulation driven by greenhouse gas force changes to the jet stream rather than simple year-to-year randomness. That word, structural, is the one that should get your attention. Scientists are careful with language. Calling something anomalous means it is unusual but essentially random, a statistical outlier that could happen at any time for no systemic reason. Calling something structural means the underlying system itself has changed in a way that makes the anomaly more likely to repeat, and to keep repeating going forward. When multiple independent researchers, looking at different regions and different seasons, all start reaching for the word structural in the same year, that is a meaningfully different scientific conversation than the one being had even 5 years ago. There is longer-term evidence backing this up as well. A team led by University of Arizona geoscientist Matthew Osman used ice core records from Greenland, combined with a climate model capable of reconstructing water isotope data, to trace the average behavior of the North Atlantic jet stream almost all the way back to the 8th century. Their reconstruction found that the jet stream's historical variations, even through past centuries of natural climate swings, have stayed within a fairly consistent range. But their model also projected that, under continued unabated warming, the jet stream is expected to shift progressively northward to the point where, by the year 2060, its behavior will become measurably distinct from anything in that entire 1,200-year natural record. That is the kind of finding that turns a vague public sense that the weather feels weird into a specific, dated, testable scientific prediction. And it is not only North America. Meteorologists in Europe documented an almost identical pattern of jet stream instability on the other side of the Atlantic. A massive northward loop of the jet stream repeatedly reformed over the first 3 weeks of one recent winter month, allowing unusually mild air to flood into France and much of Western Europe. Then, within days, that same jet stream buckled the opposite direction, a separate loop plunging sharply southward and dragging polar Arctic air straight down over the country. The result was a population that went from unseasonably warm conditions to a sudden deep freeze in the span of roughly a week, driven entirely by the same underlying mechanism, a jet stream that has lost the ability to hold a steady, moderate path. French meteorological researchers reviewing the event noted that as the planet continues to warm, the physical size of these jet stream waves keeps growing, which means when a loop does swing toward you, whether it is warm or cold, it now tends to be a more extreme version of that swing than it would have been a few decades ago. One assessment summarized the trend simply. There is no absolute certainty, but the evidence increasingly points to a direct link between the warming climate and a weakening jet stream that is more prone to collapsing sharply northward or sharply southward, rather than holding a gentle, predictable curve. This weakening and increased waviness also has a second and less talked about consequence that specifically affects anyone who flies. Research into jet stream turbulence has found that as the temperature contrast within the jet stream itself becomes more uneven, wind shear, meaning the difference in wind speed and direction over a short distance, increases. That added shear is a primary driver of clear air turbulence, the kind that occurs with no visible clouds and cannot be seen on radar, making it far harder for pilots to anticipate and route around. Researchers studying this connection have concluded that jet streams are becoming measurably more sheared because of climate change, generating more turbulence, with real implications for the future of commercial air travel, quite apart from anything happening at ground level. Now, does this mean every heat wave or every blizzard from here forward is caused directly by this jet stream shift? No, and it is important to be precise here rather than dramatic. Weather has always had extremes. Blizzards, tornadoes, and heat waves existed. long before anyone was tracking atmospheric carbon dioxide. What the research actually shows is narrower and, honestly, more convincing. Because of that, it shows that the frequency, the duration, and in some cases the geographic reach of these locked-in extreme patterns is increasing, and that the physical mechanism behind that increase, a weakening temperature gradient between the Arctic and the mid-latitudes, is well understood and consistently observed. Some individual events remain within the range of natural variability. Others, like the 2026 European heat wave that World Weather Attribution scientists calculated would have been virtually impossible without human-caused climate change, clearly are not. There is also legitimate scientific debate happening inside this field, and it is worth mentioning honestly rather than pretending the science is more settled than it is. Not every atmospheric scientist agrees on exactly how much of the wavier jet stream behavior is driven by Arctic amplification specifically, versus other factors like ocean heat waves in the Pacific and Atlantic, shifts in the Kona low pattern near Hawaii, or natural multi-decade oscillations that predate significant human influence on the climate. Meteorologists tracking the March 2026 event noted specifically that the positions of the huge northward and southward jet stream swings were likely being influenced by strong ocean heat waves in the Northwest Pacific, near Baja California, and along the Atlantic seaboard, all three of which are themselves being fueled by human-caused warming. So the honest picture is less a single silver bullet explanation and more several reinforcing mechanisms, all trending in the same direction at the same time, which is arguably more concerning, not less, because it means there is no single lever to pull to reverse it. Let us talk about what this actually means for you practically, regardless of where you live. A destabilized, wavier jet stream means the length of your local forecast window that you can actually trust is shrinking. When the jet stream ran in relatively straight, predictable paths, meteorologists could reliably project temperature and precipitation trends a week or more out. When it is locking into large, erratic loops, models struggle more, forecasts shift more dramatically day to day, and the gap between an ordinary week and a record-breaking one becomes harder to see coming very far in advance. This has real consequences. Farmers planning planting and harvest windows are working with less reliable seasonal guidance. Power utilities have to plan for demand spikes from both extreme heat and extreme cold within the same season, sometimes within the same month. Emergency management agencies increasingly have to prepare for compound events, meaning two or more extreme conditions overlapping. The way Texas experienced both an unprecedented winter freeze and later summer heat domes within the same broader multi-year pattern. Here is the actionable part, because information without action is just anxiety. If you live somewhere that has started to feel less climatically predictable than it used to, that is not just a feeling. Build a genuine all-season emergency kit rather than a heat-only or cold-only one, because the same regions increasingly get hit by both extremes within a single year. Pay attention to extended range outlooks from your National Weather Agency, which now increasingly flag pattern instability, not just individual storm tracks. If you are in an agricultural, construction, or outdoor labor profession, build more buffer time into weather-dependent planning than you would have a decade ago, because the range of what counts as a normal week has genuinely widened. And take official heat and cold advisories seriously, even when they arrive earlier in the season than you are used to. Because, as March 16th, 2026 demonstrated, the calendar is no longer a reliable guide to what kind of extreme a locked jet stream loop can deliver. If you work in insurance, logistics, or supply chain planning, this pattern shift is worth building into longer-term risk models rather than treating each event as a one-off. A locked jet stream loop does not respect state lines, national borders, or industry sectors. The same ridge that produces a heat dome capable of straining a regional power grid can, weeks later, be the same weakened jet stream configuration that allows a completely different loop to dump feet of snow somewhere that historically saw only light frost. Insurers and logistics planners who model these events as isolated, independent risks are increasingly missing the fact that they share a common root cause, which means their likelihood of clustering together in an unusually active year is higher than a purely historical event-by-event model would suggest. For everyday households, the simplest version of this advice is to stop treating your regional climate as fixed. A homeowner in a historically mild climate zone deciding whether a backup generator, storm shutters, or a more efficient cooling system is worth the investment is no longer making that decision based only on what has happened in that location over the past 30 years. The research above suggests the range of what your specific location can. Experience is widening in both directions, and planning around last century's normal is increasingly planning around the wrong baseline. Final thought. The jet stream has been circling this planet for as long as there has been an atmosphere with an Arctic cold enough to power it. It has always wobbled, always looped, always occasionally produced a strange week. That part is not new. What is new, according to a growing and increasingly specific body of research from scientists like Daniel Swain, Erica Desjardins, Michael Mann, and Matthew Osman, is the word they keep independently arriving at to describe what is happening to it. Not random, not an outlier, structural. A river of air 8 to 12 kilometers above your head, powered by a temperature difference that is quietly shrinking every year, is buckling into deeper, slower, more stubborn loops than it used to. And those loops are what stood behind a blizzard, a tornado outbreak, a heat wave, and a historic flood, all occurring across the same country on the very same day. Whatever the weather looks like outside your window this week, understanding the actual engine behind it, rather than treating each event as an isolated surprise, is what turns confusion into genuine preparedness. We will keep tracking this as it develops. Every new ridge that builds, every trough that stalls, every study that comes out connecting the dots. Subscribe so you do not miss any of it, and leave that comment below. Has your region felt more unpredictable lately, and in what way? Because behind every one of these patterns is somebody's actual week, somebody's crops, somebody's power bill, somebody's safety. Understanding that is how we stay motivated to take this seriously. 5,000 likes on this video. Let us go. See you in the next one.